In this video lecture, today we will see moment of resistance concept. The couple which produce tensile stress on tensile zone and compressive stress on compressive zone of the beam to resist the bending moment due to external loading is called as moment of resistance. Couple which produce stresses, tensile and compressive stresses to resist bending moment due to external loading. Consider one simply supported beam with one end pin and other end roller and P load acting at middle of this beam. Due to this external P load, there is bending occurs in this beam. Cut one section here, X section. So, due to this external load P, there is bending moment and shear force generate inside beam. This is shear force and this is bending moment. So, this is bending moment. The couple which produce tensile stress on the tensile zone and compressive stress on the compressive zone of the beam to resist bending moment due to external loading. So this is bending moment due to this external loading P, and this to which produce tensile stress on tensile zone. This is bending of beam, and this bottom side is tensile zone and top side is compressive zone. And tensile compressive stresses are sigma C and tensile stresses are sigma T. So see definition, the couple which produce, this is couple bending moment, this rotation is couple which produce tensile stresses, this tensile stress sigma T on tensile zone and compressive stresses on compressive zone, this is compressive zone of the beam to resist bending moment due to external loading. So these stresses, these compressive stresses and tensile stresses generated to resist this bending moment. For equilibrium, due to external loading P, there is bending moment and shear forces generates inside beam. And for for equilibrium and for resisting this bending moment, there is this stresses in compressive zone and stresses in tensile zone generates. For equilibrium, bending moment is always equal to moment of resistance. Moment of resistance denoted as capital M. When the bending is greater than a moment of resistance, the member will fails. So for safer section or side safer side of design of beam, bending moment is always equal to moment of resistance. When the bending moment is greater than moment of resistance, then the member will fail. If bending moment is greater than this capital M moment of resistance, then member will fail. here for equilibrium. So this m moment of resistance is sigma into z. Sigma is allowable bending stresses and z is sectional modulus. This XX section, illustrate this XX section. See, section XX is this. This is neutral axis. NA neutral axis. This is compressive zone. This is tensile zone. Stresses for this beam at this section is, this is sigma C, compressive stresses, and this is sigma T, bottom, tensile stresses. And at neutral axis, stress is 0. So moment of resistance is equal to allowable bending stress into sectional modulus. And moment of resistance is denoted as capital M. The couple which produce tensile stresses on tensile zone and compressive stresses on compressive zone of the beam to resist, why these stresses develop, to resist bending moment due to external loading. This resist word is important here. Resist bending moment due to external loading is called as moment of resistance. Thank you very much.